Question 22 then is about a car, and it was 22,000 new. After 2 years, it had depreciated in value to be £14,080, and we've got to work out the values of A and K, given that this situation is modelled by this equation that's given at the top. This equation, it will work out the value of the car after how many years. So we know that V is 14,080 when T is 2, and A will be how much the car starting price was, so it's 22,000. So what we've got here is we've got this equation to solve. I've got a bit more space at the bottom, so I'll do it there. So we've got that 14,080 is equal to 22,000 multiplied by K to the power of -2. So just substituting everything I know into the equation that's given at the top, and we now need to find out what K is. So we have got to find K, so I'm going to divide both sides by 22,000. So I've got 14,080 divided by 22,000. That will give me K to the power of -2. So that means that 1 over K squared is equal to 14,080 divided by 22,000. Now then, if I flip both sides, that gives me that K squared is equal to 22,000 over 14,080. So to find the value of K, we've got K squared is equal to this. We have to find the square root of 22,000 to find the value of K, because that's the inverse of squaring a number. So what I have to do is I have to type that into my calculator, and it'll tell me that K is 1.25. And A, I figured that out, that was 22,000. That's the starting price. So question 23 is a vectors question. I absolutely love vectors questions, so let's begin. So I've given that AFE is a straight line. I'm given that AF is 3 parts out of 5 in total, and that FE is shorter at 2 parts out of 5 in total. I'm given that DE and CF are parallel, and I'm given that DE is twice CF. I'm also given some other vectors. I'm given EF, AB and CB, so I have to work out DE. Now if I can work out CF, I can work out DE really easily, because I know that DE is twice CF. So I'm going to focus on working out DF. Now to work out, sorry, not DF, CF. To work out CF, I've got to know some other things. I've got to know this and this. So I'm going to work out FA first. Now I know that 2/5 of the line AE is given by this vector here, A. So I know that 1/5 is half of A. Now to work out 3/5, I've got 3 lots of A over 2. So I've just worked out there essentially that FA is equal to 3A over 2. So I've got FA, so that's nice. So I can work, I've got this part just here. What about AC? How do I go from A to C? So I'll do that up here because I know I'm short of space. So how do I go from A to C? Well, what I can do is I can do this. I can go down here and then along here. So the vector that takes me from A to C is 2B minus 3C. So 2B minus 3C, because remember when you're going against the direction that's given, the vector then is negative. So I know what AC is. So now what I can work out, because I know FA and I know AC, I can work out CF. So how do I get from C to F? Well, I will do CA add AF. So where shall I write this? I'm running out of space already. So C to F is C to A, add A to F. So what is C to A? I know A to C, so what is C to A? So C to A is the negative of this. So instead of 2b, it'll be minus 2b. Instead of minus 3c, it'll be plus 3c. So that bit's CA. What is AF? Well, I know FA is 3a over 2, so I know that AF is minus 3a over 2. Now 3 over 2 is 1.5, so I'm going to just write that in that way because I know that some of you will find that easier to deal with. So what I've got here then is I've got what CF is. I can't simplify it because I've got a B term, a C term and an A term, but I have got CF now. Now I can go on and answer the question, which is what is DE? Now because DE is given to be 2 lots of CF, remember it's given at the top here, all I have to do is double this. So really easy, so it's minus 4b plus 6c minus 3a. There we go, finished. Question 24 is about transforming a graph, so we have to understand the function notation here. So this function notation where x, this x here has been replaced by x minus 2, means I've got to translate the graph. So I know it's a translation if it's to do with addition or subtraction. So I'm subtracting 2 from the x values and I've got to translate it by 2 in the x direction and 0 in the y direction. So because the bracket has been altered, instead of x it's x minus 2, that means that the x values are going to change by the inverse of what it says. So I've got to translate this graph 2 across. So I can't just do it a little bit, I have to do it carefully. So this point where the minimum is, just there, it's going to go 2 across, so it's going to be there. This root here at 1 is going to be 2 across, it's going to be at 3. And the other root here at minus 3 is going to be, again, 2 across, it's going to be at minus 1. So I have to keep the graph exactly the same shape and size, and I have to just translate it by 2 in the x direction. So, does that look about right? It's a bit pointy at the bottom, but that will do. Part B, the graph, another graph, is reflected in the y-axis. Work out the equation of the reflected graph and give your answer in its simplest form. So the function notation would look like this for a graph that is reflected in the y-axis. So for a graph to be reflected in the y-axis, the x values here change to be over here. They become negative, and these negative x values here are going to become positive. So that goes some way to explaining why the function notation is as it is for when a graph is reflected in the y-axis. So all I have to do, now I know this, I have to replace x for minus x in this equation and simplify it. So the reflected graph will be y equals minus 3 multiplied by minus x squared plus 4 multiplied by minus x minus 5. So let's simplify this. So y equals minus x squared. When you square a negative, you get a positive answer. So that just gives me minus 3x squared. 4 multiplied by negative x gives negative 4x minus 5. So that is the answer.